Scatterplots. So when we have a scatter plot, there are three different kinds of association that we could have. Positive association means it looks like a line and it's moving upward. So as we read from left to right, the data seems to be moving upward. So the cluster is going up and X and Y are moving in the same direction. For a negative association, it looks like the data is forming a line and it's going downward. It means the cluster is going down and X and Y are moving in opposite directions. So here as X increases, Y is decreasing. No association just means I've got a bunch of scattered dots and the data does not really form a pattern. So, looking at this data set here, if it's between age and height, is there a linear association between the age and the height? Well, yes, there is. It looks like this cluster is kind of going up in the form of a line. I could put my pencil on top of the graph and be able to look at it. Is the association positive or negative? It's positive because they're both going up at the same time. And now stating the association in terms of variables. So basically, I want you to use the labels of the X and Y axis to understand this a little bit better. So I could say as age increases, height also increases, or younger kids are shorter, or the older you get, the taller you get. And then it says, what does the ordered pair 1061 mean? Well, 10 is the age and 61 is the height in inches. So at 10 years old, the student was 61 inches tall. Now we have this scatter plot, and it says about what would you expect a student's math grade to be if they had 11 absences? Well, I have this trend line here, and if I didn't have a trend line, I could hold my pencil up to the screen or look at it kind of like that. And at 11 absences, well, at 10, I'm over here at 50. So I'm not going to jump I'm not going to be above 50 for 11 absences. I'm probably not going to jump all the way down to 38. So 45 seems a better option. True or false, according to the scatter plot, a person's math grade depends on their number of absences. Well, I would say that's true. It seems to look like the more absences you have, the worse your math grade is going to get. And describe the point that is circled in words. Well, if I look at this point, it says 565. So with 5 absences, the student's math average would be a 65. Okay, the last thing we want to do is determine the equation of the line of best fit and then use it to determine how many hours of studying would result in an exam grade of 70. So to do that, I'm going to find the slope of this line by using a point that's actually on the line and this cross section here because I see that the line actually crosses at 470. So I made a table. Change in y was plus 10. Change in x was plus 2. So my slope is 5. Change in y over change in x. 10 over 2 simplifies to 5. The y-intercept I can see is right above 50, so maybe 51, 52, something along those lines. And so my equation is y equals 5x plus 51, okay? Now, if the exam grade is 70, okay, well, is that x or y? Well, if I look here, it says that the exam grade is on the y-axis, so I'm going to plug in 70 for y. If it was hours, that would be plugged in for the x. So I plug in 70 for y. I solve for x, so I subtract 51 from both sides. 70 minus 51 is 19. Divide both sides by 5, I get 3.8. If I look at the graph, 4 does hit 70, so 3.8 is an excellent estimation of what it would be.